Mathematics Analysis and Approaches, Paper 1, Time Zone 1, HL, May 2025. Now, this is question number 11 of 17 marks. He's talking about two planes here, pi 1 and pi 2, and he wants us to prove that the acute angle between them is a 60 degree. And then there is a third plane, which is perpendicular to both the given planes here, pi 1 and pi 2. He wants us to find the Cartesian equation of the plane pi 3. Now, further, he has given us some information on pi 1 and pi 2 containing some mirrors, and there's a ray of light that's been directed towards the mirror. He gives us a diagram here. So this is the light that's going to this mirror pi 1. It's reflected back to pi 2, and P and Q are here. He also says that PQ is on the third plane, which is pi 3. All right. P and Q are contained in pi 3, and then he gives us the value for PR, which is 5 centimeters. Using all of this information, he wants us to find out sine of 75 degree. We can find out sine 75 degree without the help of the diagram, but for this we will be using the diagram. Let me show you how this looks on Desmos. So this is your first plane. This is pi 1, and you can see that the perpendicular to that particular plane is that. And then we have pi 2, which is this, and the perpendicular to pi 2 is that. So these two are the planes, and we are talking about the third plane, which is this, and the perpendicular to that particular plane is that. The normal to that plane is that. So we have these three planes. They're intersecting at a particular point. All the three planes are intersecting at a particular point, and the point of intersection is that. And this point is given to us in the question itself, which is 5, minus 5, 5. So for the first question, we are supposed to be finding a plane which is perpendicular to the first two planes, pi 1 and pi 2. Now, the plane which is perpendicular to the planes are also going to be perpendicular to the normals to the plane. These are the normals of pi 1 and pi 2. So I can find the cross product between the two normals, and I'll get the third normal, which is that. And this is the normal of the third plane. Okay, so my goal will be to find the dRs of this particular normal. All I need to do is to take the cross product here. So I know that the first plane, which is pi 1, is simply equal to x plus 2y plus z is equal to 0. Now, when I talk about a plane, this is going to be the normal of the plane, and the dRs of this normal is simply I plus 2j plus k. You can also write this as 1, 2, 1. Those are going to be the dRs of the normal to the plane. What you can also notice is that the constant is 0, which means this plane is passing to the origin. So I have the first normal n1 vector as 1, 2, 1. And then I have pi 2, which is the second plane, and that is given to us as x minus y minus 2z as equal to 0. Again, you can see that the constant is not here, and therefore this plane is also passing to the origin. That is also evident from the fact that the origin 0, 0, 0 will satisfy the equation. So I have the second normal as 1, minus 1, minus 2. So I'll quickly go ahead and find the cross product between the two vectors. So the third normal would be the cross product using determinants I, j, k, 1, 2, 1, 1, minus 1, minus 2. So I can now say that the third plane, pi 3, would be minus 3x plus 3y minus 3z as equal to some constant, let's say d. What I've also been told is that the unique point of intersection of all three planes is given to us 5, minus 5, 5, which means that that point will also satisfy pi 3. And that tells me that pi 3 would be minus 3x plus 3y minus 3z is equal to minus 45. If I'm dividing the entire equation by a 3, negative 3, I would have x minus y plus z as equal to 15. And this is going to be my third plane, which is pi 3. Now I have directly gone ahead and found out pi 3. Let's also find out the angle between pi 1 and pi 2. That should have been done first. Anyways, we can do that now. So for the first plane, I had n1 vector as equal to, which is a normal, I to 1 to 1, and then n2 vector, which is a normal of second plane, is 1 minus 2. All right, the angle between the two planes is defined as the angle between the two normals to the plane. All right, so if this is the first plane and somewhere here is the second plane, and obviously they're going to meet here somewhere, but this is not the angle that I'm looking for. I'm looking for the angle between the normals. This is the first normal and this is the second normal. This angle will be known as the angle between the two planes. So for that, I'm going to be using the dot product. n1 vector dot n2 vector is simply going to be equal to if you did not know, the magnitude of any vector is simply given as the components square, sum of it, and then the root of the entire thing. So what is cos theta here? What I know is that a vector dot b vector can also be written as magnitude of a vector, magnitude of b vector, cos theta. And therefore from here I can write cos theta as equal to a vector dot b vector divided by magnitude of a vector, magnitude of b vector. So quickly going ahead and substituting that, I will have, now if I try to find the angle for a negative 1 over 2, I would get the angle as 180 minus 60, which is going to be a negative 1 over 2. So from here I can say theta is going to be a 120 degree. However, we're looking for the acute angle, and for the acute angle we're going to do 180 minus 120, which is going to give me a 60 degree. So this is the actual value for theta. We have already found the equation of the third plane, which is this. Now let's go to the C part. I need to prove that sine 75 is so and so. Sine 75 can be written as sine of 45 plus 30. And here I can apply sine of a plus b formula, and that's a sine a cos b plus cos a sine b. And yes, that's what we got. Now for the final question, which is finding the value for QR given your answer in the form of so and so, I'll be making use of the diagram. So QR is what I need to find. This is the value I need to find. So I can use the sine rule over here. I can say that sine 45 divided by, which is RQ or QR, is simply equal to this angle, whatever this angle is, and that angle can be found out using the angle sum property. So I know that it's going to be 180 minus 60, which is 120, and 120 minus 45, right? So this is 75, and that's the reason why we found out the other value, which is sine of 75. So I can simply write this as sine 75 divided by a 5, and let's quickly transpose this. So when I multiply this, this is going to be 20 divided by 4 plus root 12. Now root 12 can be written as not a 4, a 2 plus root 12, and 12 can be written as 4 into 3. Into 1 minus root 3 divided by negative 2 which is 5 into root 3 minus 1. So there you go. I got the value for P as equal to 5 and the value for Q as equal to 3. That's the answer for this question. That's it for the video. Thank you.